signals in Angular are actually very simple. We have just three functions. We have the signal, the computed, and the effect. And the effect stands out because first of all, it's still in developer preview, speaking of version 18, whereas the signal and the computed function are stable since 17. The second thing is, if you watch videos, read blog articles, also of course read something what's going on social media, you will see that there are quite a lot of statements which say don't use the effect or try to use anything else except the effect. And I think that has gone too far. It has gone too far because we see now developers are being so afraid of using the effect that they try to use a computed, for example, for those places where an effect makes sense. And then of course they end up with having poor code quality. Now in this video, I want to explain, show you some examples where an effect does make sense, where not. And I want to highlight a certain behavior of the effect, which we might be unaware of, but which causes quite a lot of risk or even danger. So, hello, my name is Rainer Hanekamp. I am trainer and consultant at Angular Architects. We provide workshops and training for Angular. And I would say, let's start. So just to be sure that we are all on the same page, a quick primer to the signals. So in order to create a new signal, I say here I have a variable n where I'm assigning a signal with number 2. This means n is now a container, a reactive container in that case, which means I can now come up with other elements like a derived value, where I say when the signal, when n changes its value, I want to do some kind of, I want to be updated, I want to be notified. So the way how I do it is that I say I have here a double, then I have here a computed, and I say I'm going to return n times 2. Now I can print it out by calling the signal. Of course, I could do the same thing also with the n. It's also a signal like double. And if I would now want to update a signal like n set here to number 4, then I can redo the console log, and the double in this case would now be automatically notified by the change in n. And what we will see in the console log is then first of all 4 and then comes 8. So let's check it out. Yeah, so here we have 4 and 8. And then next to the computed and signal, as I just said, there is also then the effect, which means we can leave the double here, but I could say, okay, just remove the console logs. I want to have here an effect. So it's a side effect, which says whenever the double changes, I want to print it out. So I have here the n set to 2, n set to 4. And now we will not get 4 and 8 in the console log, but it will be just number 8. And the reason for that is that the effect runs asynchronously. So if we would enforce that now the 2 is also shown, I need to find a way that the set to 4 is done asynchronously. So I would have to say something like a site set timeout like this. And then it runs asynchronously, which means now that the effect is first of all running the 4, so number 2, the double then to 4, and then it runs the second change ending up in the 8. That's it for the primer. If you want to know more about the basics of signals, then I would highly recommend you to watch my video. There is quite a long video that I did. We will now continue with the usage of the effect and of the computed. So, as I said before, there is very often this notion that this warning, don't use the effect, it's very dangerous. But if we look at the examples, then it's always like, yeah, I could have used a computed instead. That's very often just obvious. And of course, I will not use the effect for that. We know that. And even if in the Angular documentation, if you take a look at it, then you will see that they don't really forbid effects. I mean, it's well documented there. It's there for a reason. But they just say, let me quote it, you should avoid using effects for propagation of state changes. That is what is important. Now, most of us are already Angular developers. We have been written Angular applications already, which also means we made contact with RxJS. We know of some patterns. And I always like to draw the comparison between RxJS and the signals when it comes to this discussion. In RxJS, we say we should try to avoid using subscribes, using tabs which run side effects. We should always try, if we have one value and we want to get to another one, that we always use pipe operators and come up just with a derived observable. Now it's the same with signals. We have direct computed for these deriveds, and if there is no chance, then we use an effect. So just to show you what I mean, just to be sure, is we have here, this is a showcase component. And let's not just say I'm doing it wrong with observables. So I would have here an n observable, which is a behavior subject containing numbers. And I want to have the double again. So I don't do this, like to having just a normal value, and then I go into the constructor, and there I say, okay, I'm going to subscribe to this observable, I'm getting my value, and then I just say, okay, value times 2, that's the double. Then I take the double, use it in my template, and as we see, it works. But of course, this is wrong. That's not the way how we do it. I mean, it works, yes, but we don't do it like this. We consider it as bad practice. What most of us hopefully will do is that they say, well, this double is just another observable. It is an observable which is derived from n. We have here our pipe operator, well, and in it, we are just going to use the map function like this. In there, we are getting some kind of value and say that now this double observable should return the double amount. Now this double here is of course now also an observable, and I don't subscribe manually, but I let Angular do the subscription for me. So if I now go back, we see it's the same result. And if you're new to Angular, you might ask the question, yeah, and what's the problem with the thing that we had before? As I said, there's not really a problem, it just worked, but well, I mean, this is now more readable. It's not imperative in that sense. I don't need to explicitly subscribe. I don't need to explicitly define what should happen during the subscription, but I'm just connecting my double to the existing source, which is n, and I'm defining the mapping operation that should happen. And it's the same with signals when it comes to computed and effect. So if I would say here, I have a signal n, it's signal 1, and then I have a double, which should also be a signal. Let's just say we initialize it with 0. Then I would call it here. And again, what I don't do is that I say here I have an effect. And this effect then says, okay, what do I want to have? I want to have the current value. I want to track the signal of n, like this n. And then I want to manipulate the other signal, the double, because now I want to set double value times 2. Like, save it, then we can check it out if it's working. Now it's the same thing that we had before with the observable. We can say, yes, it is working, but this doesn't look right. Why don't you just use a computed for it, that what the computed was made for? So we obviously say, okay, as I've done it before already, computed, and then I say here, this n times 2, and I can get rid of the constructor. Again, much easier to read, and this is what I think, again, most of us would do just naturally. And again, this is the problem with the current discussion, I think, that we know all of this already. We would not use an effect for that, but nevertheless, we are very often told, don't use the effect. So the question is, when can we now use the effect? I have prepared some examples here. So we have the common use cases for an effect, which is maybe I want to log something when a signal changes. Or I want to do a synchronization with my local storage, also when a signal changes. Now these are all valid use cases. In short, we can say whenever I want to run a certain side effect which does not have any impact to another signal. So I don't want to update any other signal. There are also other ones. So these are the simple ones. I have here, for example, a chart component. Now what this chart component is doing is that it's obviously showing here your charts, and it could now happen that there is now something, an input, as we see it here, chart data, which we want to use to regularly update our data in the chart. So the question is, well, how do I do it then? In my case, there is no property binding from the data, so I cannot directly use it in the template because I'm using, in this case here, a third-party library, and I'm directly communicating with the DOM. And that's a valid use case for an effect. So what I have to do here is that I say, okay, I have to override this chart variable here whenever the chart data changes. And that's why I have to use an effect, because this is a side effect. There is simply no other way to do it. So what I say, I'm creating here an effect again. Maybe also provide here a good name for it. So I say update data effect. Then I start with the tracking. So I say here chart data, which is the value, is this chart data. And as you have seen already before, I'm somebody who is really careful when I'm using an effect. So I have always one part where I'm defining those values that I want to track. And then I have a second part where I'm doing my actual processing of the data. And that I always put under an untracked. So in case some code of my processing is accessing another signal, that I don't start to track that signal as well. So that's why you will always see me using here an untracked. Yeah, what do I do with this untracked? Well, I go to my chart. First of all, I need to check if the chart actually does exist. So this chart. And then I say, well, this chart, there is a data, there are some data sets, there is just one, which I'll take, and then I'm going to override it with the value that I have just received. So let me quickly scroll here to the top. And that's the only way how I can do it again. Constructor has been imported. That's not the right one. And if I go back, we should now see that, I guess, in 2.5 seconds that this chart here is updated. And it isn't. Yeah. Good. And now it's updated. Valid use case of an effect. Another common use case is, for example, with reactive forms. So I have here my customer component, and again, you see that I'm getting here a customer as an input, coming already as a signal. So I need to react to that particular signal, and it's not that I want to now to create another derived value, but I need to synchronize now my form with it. So in a way, I'm coming from a reactive context, or from a, let's say it's a reactive context, and I want to switch now over to a non-reactive context. I need to come up with a bridge, and that's what the effect is doing here. So I say here, I have my form group update, again, effect, and I say this form group, set value, and again, I'm calling here this customer signal. So whenever it changes, that my form group is now getting those new values. So I go back, and we see now this kind of form has received its values. So until now, this has all of these things. They have been in a way like synchronous changes, but not impacting any other signal. Simple side effects. There is now also something else where we could say, yeah, but now we have an asynchronous task, and we will, in this asynchronous task, always also update another signal. Also that is a valid use case for an effect. And in my opinion, that is actually the most common one, at least in those kind of applications that I see. It is actually the container component for the edit customer form that we have seen before, which is fetching the customer from the backend. So if I click here on a certain user, then you see the ID of my customer 20 is part of the URL. Now I have already enabled here the router module with provide router with router component binding, which means that the ID here is already taken from the URL, again in the form of a signal. That's the modern way. Now again, the question is, okay, and now I need to kind of go to my backend. We have here already my customer service, which will do this for me, but I have to do this in an effect. So what do I do? Well, again, I say fetch customer effect, or however you want to call it. And I say it's just another effect, where I say const ID. I'm going to track it again, then untracked. Now I'm starting with my asynchronous task. So I say now, this customer service by ID, provide here the ID. That one will return me, in this case, a promise. It could also be an observable. But in the end, I'm getting my customer back, and I'm going to use that customer now to set another signal. This customer set customer. This is what I have to do. If we look into our application, we see it's working. It's not the same customer where I've clicked on, but that's another issue with the backend. But we see here asynchronous tasks together with updates of signals. Of course, also with the safety net of having an untracked, yes, but this is a common use case for an effect. And if you have been doing this so far and had bad feeling about it, don't have it. You can forget it. It's the right way on how to do it. That's the typical use case for an effect. Actually, in this case, we could also discuss the use of the untracked, because here we have the signal change, which comes in the asynchronous task, which doesn't mean that now this customer is tracked by my fetch customer effect anymore. Nevertheless, again, for safety reasons, we don't know what this customer service by ID is doing here. If that one would internally access another signals, it would also track here. So this effect would then also track it. And that's why I don't want to have it and use the untracked. The other thing is, what I've seen is that you could say, well, I don't need to use I can't use the effect. I need to use the computed. Is this also possible? Yes, I mean, you can say I have here a computed. You can switch from the effect to a computed. We might have to come up with a better name. I mean, the untracked will not help me here that much. What kind of name can be provided? Let's just say as a foobar. But we will see. I mean, it looks like there is not really a problem if we use a computed, but we will see there is a problem because nothing shows up. Whenever we have a signal and computed produces me a signal, we need to use that signal inside of a reactive context to make it active, to activate it. So although I'm not doing anything with this foobar here, it's just there for a side effect, I still have to use it in my template. So what I would have to do here is that I have to say here, okay, I'm going to call foobar. And with that, I mean, I have to hope that it doesn't return anything. It activates itself and it's running internally the side effect. But I hope that we don't do this, that we don't want this. This is really kind of like, I'm doing everything, even if it doesn't make any sense, just to avoid the effect. And as a bonus, it's very unreadable, because whoever reads this thinks, what wanted this person try to do to come up with a computative foobar which I can't use, and a computative which runs actually a side effect. That is very strange. Another discussion point might be here, do we actually have to use an effect? Is it actually the best thing to do? Why didn't we go with RxJS in this case? Very often we hear RxJS is good for asynchronous tasks. RxJS is very good when we need to manage events. So a perfect fit in this case for RxJS. Yes, probably we can go here with RxJS. Maybe the criteria when to go with RxJS, when to go with effect is content for another video, but you still require an observable. And you have a signal. You have here the customize a signal. So what we usually have to do here is that we have to use the toObservable in order to be able to use RxJS. But guess what? toObservable is also using effect under the hood. So it's not like when you say you are using RxJS that you are replacing it with the effect. It's still the effect, it's still there. So again, I hope that you have now seen some of the common use cases where an effect makes sense, or in other words, where you don't have any other choice. That's a perfect use case for an effect. And we will now continue with another thing where you might say, yep, an effect is the better choice here, but where I would say, no, this is something where you can't use it, where you are not allowed to use it. So we have now the following use case. We have here an online shop where we are selling different fruits. So I can click here on banana or on apple. Then it says, yeah, apple has been added to the baskets. I also have here the option to update the amount. We see here also there's obviously a network request going out with the ID and the amount. And if I go to banana, for example, then that one is also added to the basket and the amount switches back to number 1. This is the code. So we have here the message service for the message, then the HTTP client obviously for the request. And then we're doing as much of the things as possible with signals. So we have here the selected product ID. We have the selected product, which derives from the selected product ID, returns the full product. And then we have here the amount. The amount is the signal which we are using here in the engine model. So we have here two-way binding in that case. And this is not the important thing, we use an effect. We use an effect to reset something. So we say whenever the selected product is going to change, so we track it, then I want to reset the amount signal to its initial value, which is 1. Could I have done this with a computed? Don't know yet. But I would say this is the way, and very intuitive, a very readable way on how to do things. We have here our select product. So this is this event listener that happens if I click on a product. It changes here the product ID, obviously, and then it shows here this message. And then we have here update amount, where I'm saying, okay, I'm sending now the request out to the backend. Why does my select product not already reset the amount? Well, because I want to play it safe. What I'm saying is, I don't know how many features are there that could change the selected product. I want to play it safe. I want to really kind of connect the change of the signal with my reset mechanism. That's why I put it here into an effect and out into the select product. So far, so good. And now there is a new request, because if I click here on select product, then I also want to send a message to my backend. So I also want to say here this new product has been added to the basket. So this means I'm going to say, okay, this HTTP client post should also happen here. So far so good. Let's go back to the application and try it out. So I click on Apple. ID 1, amount 1. Good. I click on banana. ID 2, amount 1. Good. Looks like everything is working. Reload the whole thing again. Again, click on Apple. I'm going to change the amount. Click on update amount. Yeah, still the right information, ID 1, amount is 3. Now I click on orange, and now it says ID is 3, amount is 3. Although amount here shows up with number 1 in the input field. But what's going on? This is really strange. Actually, it's not just strange, this is a huge bug which we have right now, because if this is a real online shop, then your end users will be a little bit disappointed or even angry, because they clicked on another product in the belief that they are just adding 1, but what they did is that they added now 3 of them. And if they are not careful and watch exactly the numbers of the basket, they are ordering 3 products instead of 1. This is something we don't want to have. Why did this happen? The reason is the effect. Unfortunately, it's the effect in this case. Because the effect, if you remember, always runs asynchronously. And that's the problem. We have here an event listener which runs synchronously. And the event listener depends that the computed or that this kind of updates of the signal is also done synchronously. So if I'm setting here the product ID to another ID, I would expect that my effect is then also resetting the amount, which will happen, but asynchronously. For my event listener, that's too late. The event listener will get the old amount, and even more disturbing for the user, for the front end, that one will get already the real one because the effect has already run, in this case, before I could actually see this kind of glitch-free effect or this rendering update. So that's a real problem in this case. And this is something where that you really have to remember. That's the main message of this video. You can use the effect for synchronous operations as long as you don't touch any other signal. That's fine. For asynchronous, it's not a question. You can use the effect. That's not a problem. But for these things, you must not use the effect because you're running into this asynchronous problem. Even if we would draw now that comparison with RxJS, RxJS behaves differently there. Because if you have a side effect, if you have a tap, or if you have a subscribe with an observable, they will run synchronously. This, the effect not. So you can see actually an effect as a subscription or as a tab operator, which runs the method, but it runs the method in an inner set timeout. This is what the effect is doing. Now the solution for it is that we have to do it with the computed, because the computed runs synchronously. So the computed will get notified by the signal synchronously when its producer changes, and it is aware of the change, which means if the select product will access it, it will return it, here we are, it will return it the right value. How does it look like with the computed? Now this pattern actually, this reset pattern has been introduced by Alex Rickerbo at Tech Stagnation, and it looks a little bit unintuitive. We call the variable where we are going to store the value, the outcome of the computed, we call that state. And the idea is that we say we have now 2 types of signals. We have one signal type, which is the parent signals. They are the triggers for the reset. And then we have obviously those kind of signals which are affected by the reset. You can also see them as the child signals. The child signals are nested signals of the computed. How does it look like? Parent signals first. So I say here selected product ID is coming from selected product ID. So we are tracking it here. This always runs with product ID changes. And then I have my amount. And the amount is now an own signal actually. It's a signal in a computed. Where I say it's resetted to number 1 all the time. Let's think it through. This one here, if the amount changes, if the signal here changes, then this change happens internally. And the computed does not run because of it. So I can change the amount as often as I want. The computed of the state will not rerun. It only reruns if selected, product ID changes, and this is what I actually want. And when it reruns, it's kind of causing also a side effect, namely resetting the amount, adding a new signal to it, which has the initial value of number 1. That's the idea. And it also works. So of course we have to change some things now. The amount does not exist anymore. It's part of the state. So I have to remove here, or let me comment out the reset effect. In my template, I need to use state. I need to call it. It's now a signal, and I need to access the nested signal in that signal. That's the confusing part, at least for me. I thought, what's going on there if I saw it when I saw it the first time? Here I have to do the same thing again. So I have to use here state like this, and I think we are done. Yep. So if I go back now and I say here apple, and I say here 3, update the amount, and click on banana, then it says here amount number 1. You could now say, yeah, but before you clicked on orange, not on banana. Yeah, then let's try it with orange. So I say here 3, update amount, click on orange. It's also working. So again, synchronous updates of signals, it's forbidden to use an effect unless you really know what you're doing, because here you are causing asynchronous updates of inside of the effect. Don't do it. Always try to go with computed in this case, even if it's not that readable. So you really have to sacrifice readability for avoiding bugs in that case. Okay, so that was it already. If you have any questions, any comments, then just please ask. And for the summary. So we know there are use cases, there are valid use cases for effects. We just have to know which ones they are. So we can use effect whenever we have some code, some side effects that don't change any other signal. We can also safely use an effect if we need to trigger asynchronous tasks. The question again, should we use RxJS for that? But generally speaking, effect asynchronous tasks, that's fine, that's safe. Careful when you have an effect where you do synchronous changes to a signal. This is dangerous. Even if you would say, well, the computed version looks very complicated, very hard to understand, it doesn't matter. Don't go with the effect, because the effect always runs asynchronous. That's the problem. Luckily, the Angular team is aware of it. So Alex Ricopo has presented this reset pattern, and he's the tech lead of the Angular framework. So we can expect that in the future versions of Angular, we will get new utility functions, which will kind of wrap the usage of the effect or the usage of the computed, depending what is actually possible, and will make it much, much safer for us to use it. At the moment, functions that are already using the effect are the toObservable from the Angular framework itself, Rx method from the signal store, and the one that I really like is the explicit effect from ng extension. So I would say that's it. You now know that you can use the effect. Just remember, last sentence, an effect is not a synchronous side effect, it's an asynchronous one. Thanks for watching and see you soon. Goodbye.